I would now like to introduce John Rice, who will kick off the webinar. John works for the Bureau of Reclamation and is the Science Coordinator for the Southern Rockies LCC. Welcome, John.
Thanks, Mary. Today I get to introduce everyone that is going to be presenting to us today. Then I'm going to try to frame up the project so that you sort of understand the scope, the purpose, and whatnot. And then I'll run through a quick outline of what's going to be discussed and by whom, and then we will move on down the line through the rest of the presentation. So you'll see that I'm not really a presenter, but I do have something to say. So today with us are Mark Holden. He's the Executive Director of the Utah Reclamation, Mitigation, and Conservation Commission. And if you are all astute, you'll see that there's no commas in that name, and I'll let Mark explain that. And you'll also think Utah Reclamation, well, that must be a state agency. I'm going to let him handle that question also. He's going to give us a little bit of the background on the project. Then Melissa Stamp is going to talk to us a little bit about the model. She's a project coordinator for the Utah Mitigation and Conservation Commission. And she actually worked for BioWest at the time this particular project was conducted by BioWest. And then Daryl Devey is the Bonneville Unit Operations and Management Manager for the Central Utah Water Conservancy District. So he's here to give us a perspective from the resource manager as to how this all worked out. Darren Olsen is on the phone. He's not feeling well today, so we really appreciate your being here, Darren. But he was the project manager for the project at BioWest when it was conducted. So to sort of frame this discussion and this project, I'd like to sort of put it into context by talking about, you know, what was the issue or the problem, what was the solution to that problem, and what was the outcome from that. And so the issue in this case is seedling recruitment, because seedling recruitment is critical to sustaining new channel or near channel riparian forests along the Provo River, and probably any other river that you can think of. The solution to this was to develop a conceptual model of seedling recruitment that quantified three key factors limiting cottonwood recruitment, and that's the influence of site hydrology, seed release patterns, and the seedling water stress thresholds. The outcome of this project was a model simulated recruitment that enabled reservoir managers to design efficient and ecologically beneficial flow releases. So you'll already probably be grinding the gears saying, well, gee, you talked about seedling recruitment and went just to cottonwoods, and you're right. Cottonwood is sort of the surrogate for the rest of the native vegetation in the riparian corridor. As you'll see pretty soon, there's another surrogate here, and that is we used a single reach of the Provo River to serve as the surrogate for the rest of the river. But I think what you will see in the end is that even though those assumptions are quite tenuous, or could have been perceived as being tenuous, they really worked out quite well, and the success of the project, or of implementing the project, has been quite significant for restoring the Provo River. So just as a quick run through here, if I can get my cursor to cooperate. This is a photo of one of the side channels that was constructed along the Provo River during the Provo River Restoration Project. And it was taken shortly after construction, and you can see a lot of seedlings in there just beginning to come up. Oops, that's not working very well. This photo taken in 2004 of that same location shows the amount of recruitment that can be done by Mother Nature when she has the chance to work her magic. And then by 2006, you can see just how successful this area is really starting to become. And so with that in mind, then I'm going to turn it over to Mark Holden in just a minute. He will tell us about the background of the Central Utah Project and the Provo River Restoration Project. Melissa is going to talk to us about the recruitment modeling tool that was developed. And then Daryl Devey and Mark Holden will talk to us about the reservoir release decision making. And then we will all wrap it all up with questions, and Darren Olsen will help participate in answering the questions. So with that, I will turn it over to Mark.
Okay, thank you, John. I appreciate the opportunity to talk to you all today and present a little bit of information. We're going to run through this kind of quickly. There's obviously a lot of additional background and supporting information, but we wanted to give you a sense of what we did here on the Middle Provo River in Utah. First thing, I should tell you a little bit about our agency. We are a federal agency. We were established in 1992 under the Central Utah Project Completion Act. And under that act, our commission was created and given the primary authority to conduct the fish, wildlife, and environmental mitigation program for the Bonneville unit of the Central Utah Project. The Central Utah Project really has its history in starting in the Colorado River Storage Project Act of 1956. Most of you are probably familiar with the Colorado River drainage and understand its significance to these western states as a water source, but also as an environment for a lot of the fish and wildlife that we all value highly. As originally conceived, the Central Utah Project consisted of these 5 main units. 2 of these units out near the town of Vernal in the Uinta Basin have been completed, and they provide water resources for the local area, primarily irrigation, but also some M&I water use. There were 2 other units that were originally planned as part of the Central Utah Project, and they similarly would have developed water supplies by constructing dams and conveyance facilities to support irrigation in the Uinta Basin of Utah. And then the Bonneville unit, which is the largest unit, is the unit that accomplishes a trans-basin diversion. It takes Colorado River drainage water, collects it, and stores it in Strawberry Reservoir for moving it over into the Wasatch Front. And this is the largest unit of the Central Utah Project. It's the unit that was really the focus of the Central Utah Project Completion Act, and the authority for completing the Central Utah Project then was given to a state entity, the Central Utah Water Conservancy District, for them to plan and construct the remaining water development facilities. And so there's been this partnership established among Reclamation, the Commission, the Department of the Interior, and the Central Utah Water Conservancy District for many years. Under CUPCA, the CUP Completion Act, the 2 prior units that had never been constructed in the Uinta Basin, those were deauthorized, and the Bonneville unit was expanded a little bit to pick up a couple of projects for local water use in the Uinta Basin. The reach of the portion of the project we're going to be talking about today is on the Middle Provo River, and it's located between 2 reservoirs, Deer Creek Reservoir at the downstream end, which was a pre-existing, and by that I mean it was constructed in the early 1940s, and it predated the Central Utah Project. The other reservoir at the upstream end is Jordanelle Reservoir, and that was built as a part of the Central Utah project. And so the segment of river that we're addressing here today in our talk is between those two dams, located about 10 miles apart from Jordanelle Dam to the upstream end of Deer Creek Reservoir as a straight line. It's important to realize a couple of things first about how the project operates, and this is a diagram of the watershed, Provo River watershed. Jordanelle is fairly high up in this watershed, but the main thing I need to point out is that the Deer Creek project, when it was constructed, relies substantially on transbasin diversions of water. There's one from the Duchesne River system, which is a Colorado River tributary, into the upper Provo, and there's another that comes over from the Heber River, which is an adjacent river drainage here in the state. And operationally, those sources of water would be added into the flow of the Provo River, and consequently what happened over a period of time was that there was extensive flooding that was caused by these diversions. The solution that was come up with at the time back in the 1950s and 60s was to channelize and straighten the majority of the Middle Provo River. Like I say, about 10 miles of river. When the Bonneville unit came along and Jordanelle Dam was constructed, it provided a measure of flood control, and that afforded us the opportunity to help conduct a restoration project on the river channel between the two dams. This was a long-term project. It is a long-term project. The initial ideas for it really began in the late 1980s when the CUP Completion Act passed in 1992. Things really got rolling with a lot of planning, public involvement, NEPA compliance, and so forth. And then from 1998 through 2008, we implemented the project. And that involved a lot of land acquisition from over 60 landowners and restoration on the Middle River. These are actual photos. This is what used to occur sometimes in the Middle Provo River up on the upper left. The Water Users Associations would come in and scoop out and dish out the river channel in their attempt to facilitate flow. And this is an area that's upstream of Deer Creek Reservoir on the very bottom end. In the middle of the valley, between the two reservoirs, there was one segment about 1.5 miles long that was never channelized. And as you see this image, you can view all of the different meander scars and locations where the river's migrated across its floodplain over time. We use this information somewhat as a template for guiding our restoration designs. Obviously, there was a main channel, but it was also supplemented by a lot of back channel, cutoff channels, and even side channels out in the floodplain margins. And so that's the type of pattern that we incorporated into the project. This is an aerial view of the reach of river that became the study site for the riparian recruitment we're going to be talking about. And it was channelized, very straight stretch through here. The design that was developed involved a main single thread, some other cutoff and back channels, as well as some side channels. We still provided some degree of flood control if we needed to by constructing berms kind of at the margins of the floodplain rather than adjacent to the river channel. And this is a photo of that area, the year that construction was completed on it. And we have another photo taken a dozen years later. I apologize, it's kind of a washed out photo, but it does show a lot of the vegetation recruitment success. Now I'm going to turn this over now to Melissa, and she'll talk to you about the modeling process and how we've applied that.
All right, thanks, Mark. I'm going to try to get through this modeling details fairly quickly so we have plenty of time for more discussion of how things have fared in the 11 years or so since the modeling work was done, and also leave time for some more questions. So I'll be getting into the details of this model, and this is work that was done right around 2003 as part of the Provo River flow study. Before I get too far into the guts of the model, just want to touch on the importance of riparian vegetation. And that could certainly be a whole webinar series unto itself. Riparian vegetation provides a whole host of ecological services and functions to our river systems. But just to touch on a couple, just highlighting a couple of things, it's very important in terms of aquatic habitat. A lot of people like to go fishing, so fish get a lot of attention. So it's important to remember how important this woody vegetation is for aquatic habitat, both in terms of providing in-stream cover and habitat complexity, scour holes, those types of things. Riparian vegetation is also extremely important for providing good water quality, shading to protect water temperature, nutrients, a food base for the aquatic ecosystem. And riparian vegetation is also intimately tied to channel morphology. So things like log jams provide velocity, lower velocity areas where bar deposits can form and our riparian vegetation can develop. Riparian vegetation can also provide a lot of bank strength and affect erosion rates and that sort of thing. So just a real overly brief version of what matters about riparian vegetation. So John already kind of touched on this a little bit, why we're focusing on cottonwoods. There's a few different reasons. One is simply that it's the dominant native riparian tree in the western United States. It's also unique in some sense that its recruitment success is highly dependent upon fluvial surfaces and flows. And if you have a system where you're seeing good, regular recruitment of new cottonwood trees, it's an indicator you have a healthy ecosystem and that a restoration project has been successful. Just to be clear, when I say recruitment, what we're really talking about is that whole progression of a cottonwood plant from starting as a seed to a seedling, sapling, and ultimately into a mature tree. So essentially, how we get new trees and keep the forest healthy and thriving. So the same reasons that cottonwoods are such a good indicator of ecological function are the same reasons that they're susceptible to the effects of dams and diversions. They require that flooding and disturbance and fresh sediment that tends to get affected by dams and diversions that block floods and also inhibit sediment supply to the downstream reaches. And because of these reasons and other factors like invasive species, cottonwoods on many western rivers are now limited to old growth stands where the trees are now in the neighborhood of 100 years old. They're just dying of old age. And so it's a problem throughout the West. This is just a small subsampling of river systems that have been affected where there's some literature or research or programmatic efforts related to cottonwoods. And I have a picture of a bald eagle on this slide because on the Missouri River in particular, which is really a series of connected reservoirs operated by the Corps of Engineers, there's a lot of concern because the cottonwoods are starting to die, they're not being replaced, and there's no real alternate tree species providing tall trees for eagles to nest in and to roost in. So birds matter too, not just fish when we're talking about riparian vegetation. So it's an issue throughout the West, which is probably why you guys are on this webinar. Another reason we focus on cottonwoods is very practical. There was a good body of research existing outlining the recruitment criteria, and that allows us to use cottonwoods as kind of a surrogate for other native woody plant species such as willows. So getting into the details of this model process and project, The study was funded by the Mitigation Commission. I work for the Mitigation Commission now. As John said, at the time I was working for BioWest and was involved with some of the field work and modeling work. BioWest was the primary contractor with help from Institute for Natural Systems Engineering at Utah State University. Craig Adley was the person who did the actual detailed River 2D model that generated these nice images on this report cover here. Geographics also helped with GIS components of the project, and Central Utah Water Conservancy District provided data and support for the Provo River flow study as well. So, I'm just going to warn you right now that our model is wrong, but we were hoping to make it useful. We had some specific objectives for the model, hoping to kind of look at being able to assess our alternative flow regimes and look at the effects of the restoration designs on riparian vegetation. We also really wanted to be able to develop some flow recommendations to try to maximize riparian recruitment in these restored reaches where so much time and money had already been invested in physical channel reconstruction. So again, Mark kind of covered this, but our study area is up in near Heber City, east of Salt Lake in northern Utah. And we're talking about the Middle Provo River, which covers this stretch between Jordanelle and Deer Creek reservoirs. And our study area is right here at this pink star, about 3 miles downstream from Jordanelle Dam. And our study area was a 3,000-foot-long reach where restoration was completed in 2001. Just another before and after shot. Mark had already showed you this. Our reach that was modeled is this section between the pink arrows. So first step in coming up with the model was doing a lot of topographic surveying. So getting out there, getting many, many hundreds of points, probably thousands of points with our total station. That data was also supplemented with some 3D orthophoto interpretation, sort of stereoscopic, higher tech stereoscopic photo interpretation that the Utah State folks, Craig Adley's group, did for us. And ultimately we wound up with a very detailed topographic mesh with 250,000 nodes, each about 1 square meter in size. Overlaying onto that terrain model was the hydrodynamics model, which is just a fancy way of saying a model that allows you to use topography and roughness information to relate water elevation to discharge. And River 2D was the software package that was used for that model. It includes a groundwater component. And so you end up with 2 outputs from the model, water depth and velocity. And those outputs are available for each of those 250,000 nodes in our model for a given flow. So next step in completing the model is overlaying the Cottonwood recruitment criteria. So I'll just start with a quick review of the general requirements for seed-based reproduction. I think there's some folks on the call that probably know a lot more about this and have done some of the scientific research around this. So maybe at the end of the webinar, you guys can chime in with what I've gotten wrong here, but hopefully we're close. Some of the general requirements based on a publication by Scott et al. In 1993, kind of 4 main steps, requirements. First is that a moist bare surface with fresh sediment be available at the time of seed dispersal. And then those seeds, cottonwood fluff, needs to actually be transported and deposited onto that bare sediment surface. And then once we've gotten lucky enough to have that happen, the post-germination decline in the water level needs to happen slowly enough that the growing roots of the seedling can kind of keep up and not dry out. Last general requirement is the absence of floods after germination that would scour out those seedlings. This is just a graphic illustration of some of those general requirements, showing the importance of the bare sediment becoming available during the seed release period. And this green line is just sort of a general indicator of an acceptable receding limb rate, sort of a ramp down rate that's slow enough to allow those seedlings to keep up. And this recruitment box concept is well developed in the literature. Mahoney and Rood in 1998 published the recruitment box concept, and various folks have taken it from there. But the idea here is just that there's a fairly limited box of potential success when you're talking about cottonwood recruitment. So we took those general requirements and inserted them into sort of rules or parameters in our hydrodynamics model. So the first rule was that a node to become live and potentially a successful recruitment spot needs to get wet and then exposed within the seed dispersal window. And we kind of looked at the literature on cottonwoods for our particular study area. May 30th to July 19th is the seed dispersal window in this part of the Provo River. Second rule in the model is that within 10 days of being wetted, we wanted that soil surface to still be moist and viable for germination. And that rule was kind of put in the model by looking at the groundwater level relative to the capillary fringe. Next rate was making sure that the recession rate wouldn't be greater than 1 inch per day, calculated as a 5-day moving average. And at the end of our model run, the rule was that the water surface could not be more than 1 meter below the ground, because that's kind of the general guideline for how deep cottonwood roots can get in one first growing season. Then the last requirement is that that node not be re-wetted again after the seed dispersal window. So model input's real simple, 92 daily flows. We just looked at the May 1st to July 31st hydrograph period. And at each node, the model's going to track recruitment success. It'll become live and turn green. You're going to see some color coding in the next slides if it meets that initial criteria. And then the node's going to die if all those criteria are not met. It could die blue death by an overly fast recession rate. It also could suffer red death, which I'll get into, if it's re-inundated outside the seeding window. If it gets re-inundated during the seeding window, it's going to reset and go live green again, and then the model rules will kind of be reapplied a second time. Final output is how many live nodes do we have at the end? How many square meters of recruitment success do we see at the end of a given run? And we'll also be able to output a video file, and I'll share one of those with you. Oh, this is my visualization of what life is as a cottonwood model node in our model. It's like running the gauntlet. So if you initially get turned green, you get to run the gauntlet, and you try to escape desiccation and suffering blue death or red death by re-wetting. If you make it through that spring hydrograph through your model run, at the end you'll be a live node. So it's a little bit rough to be a cottonwood seedling, but some will make it. This slide is just a reminder that we did some model verification in 2003 during pretty high water year that year. So we went out in the field and looked at what areas were getting inundated and where we saw some live seedlings later that same season, and did some tweaks to the model parameters to kind of match those observations. So John already kind of hit on some disclaimers, and got 2 full slides just to convince you our model is really just a tool, and it's going to be wrong, but hopefully useful. Again, it's only relevant for seed-based reproduction, and cottonwoods do reproduce vegetatively and have done so successfully in quite a few areas of the Middle Provo River. The other important thing is the model only runs you through the gauntlet one time. Those seedlings are going to have to survive again the next year, and our model doesn't look at that. We definitely don't account for all potential criteria. We're just basing this off of a surface water discharged based hydrodynamics model. So it's just looking at surface water and surface water influenced groundwater. And there are definitely other sources of water that could sustain cottonwoods, even if the model says they would not make it. One other important point that we don't kind of incorporate in our model is existing plant cover. The model does not know if a particular node is bare sediment, which is kind of what's needed for that germination to start off and become really live in real life, or if it's covered with a whole bunch of grass and really a cottonwood would never get started there. So definitely just a tool. Again, we were only modeling one study site out of the full 12-mile stretch of the restored Middle Provo River. And there's a lot of variability in that 12 miles. And so even if our model is saying a particular hydrograph is less than ideal for recruitment, it may be more ideal in a different reach. Okay, hopefully that's enough disclaimers. Now I'll show you this model run. What we have here is a sample input hydrograph, and we have time on the x-axis, May through July, discharge on our y-axis. These blue crosses here on the hydrograph are the time steps for the video output that I'll be showing you. And I want to point out two main things. You can see here between time steps 2 and 3, we have a very steep drop in the hydrograph. And then here between time steps 9 and 10, kind of just at that tail end where we're no longer in our seeding window, we have a small increase in flow. So that's kind of a red flag for potential red death. So this is the video. I'm going to run through it once in slideshow mode. It's going to go really fast, so I'll then step out and show it to you step by step. But you'll notice as I do this, some areas will turn green, then blue, and some red. So those are our green means it's a live node, blue means it suffered desiccation, and then red as it was re-inundated. So that's kind of the fast version, and I'll step through this a little bit more slowly. And you'll see not much is happening initially because none of the nodes have been wetted and exposed yet within the seeding window. But there between time steps 2 and 3, you see we suddenly have green areas and blue areas. And those are areas that are now exposed, and then some of them have already experienced red death with that rapid recession rate. And as we continue through, we have some more areas turning blue. We have some other areas turning green. These are areas that are now becoming exposed as the flows recede. And then I want to highlight this 9 to 10. So you can see we have green here along this side channel at time step 9. Then it kind of disappears. It's a little hard to see, but that's actually turning red, and that's where that re-inundation happened. So I'll just run through it one more time in the slideshow mode. So that's kind of the output that we were getting out of this model, a nice visual tool. So now I want to that gives you an idea of how the model works. I want to show you a couple of sample hydrographs that we used and modeled during the flow study. So one of the applications of the model, one of the ways we wanted it to be useful, is to be able to compare recruitment success under different hydrograph patterns. So here in pink we have the 1993 hydrograph, and that's a hydrograph from before Jordanelle Dam. In white we have the 1999 hydrograph, which is after Jordanelle Dam. And a couple things to point out. We have a slightly higher peak in 93, but it's actually before the seeding window, a little too early in May. Both hydrographs have pretty similar, fairly rapid receding limb rates in this portion of the hydrograph. And then again, this pinkish red hydrograph line in the 93, we have that late season increase in flows that again is a potential cause of re-inundation death because we're outside the seeding window. So when we run these hydrographs through the model, this is what we wind up with. We wind up with about 16,000 square meters of successful live nodes at the end of the model run under 93. And in 1999, about 21,000 square meters. I want to point out our red areas here in the 1993 scenario where there was a fair bit of the red death, the re-wetting that happened in August. And the other thing I want to point out is there was more water in the 1999 hydrograph scenario, but only about 4% more water based on a kind of an annual acre-foot comparison. And with that 4% more water, we wound up with 25% more cottonwood recruitment. So point being, it's not just a matter of throwing water at the problem. It matters a lot how that water is sent down the river. To illustrate that and look at that a little bit more, we wanted to look specifically at a couple of services that we're interested in maybe cottonwoods establishing. So we did some modeling on some island areas. We looked at nodes that were on these island areas and developed some water depth versus flow plots. We have water depth here on the y-axis, flow on the x-axis. And the main point I want to make on this slide is that these lines are not smooth. It's not just one nice straight line across this plot. There are two areas with particularly steep drops. This first one is between 1,400 and 1,200 CFS, and another one here between 400 and 300 CFS. And so we used that information, looked at a couple different islands, some other nodes in our model, and used that to come up with recommendations for rates of decline to promote successful riparian recruitment. So these are kind of ramp down rates that the water managers can use to kind of plan or try to target flow releases to promote cottonwood recruitment. The main point, again, I want to make here is that it's not just one number. There are some areas in the topography out there that are steeper, where a slower rate of ramp down is more important. But, you know, up here at the highest flows where our broad, flatter floodplain is inundated, you can drop things pretty quickly. But those kind of sensitive spots are 1,400 to 1,200, and then again here between 400 and 300. So we used these recommendations to kind of look at some target hydrographs and run scenarios through our model. And in this case, we have in pink here the actual gauged hydrograph from 1999, and then we ran a couple of target versions of that hydrograph where we modified the release rates using our recommendations, the guidelines in the previous slide. And this blue line here, the improved scenario, is using sort of the mid-range of these guidelines, and then the maximized is using the slowest, the most conservative version of those guidelines. And that's what that looked like. And when we ran that and got our results, we're kind of encouraging in that, again, it's not a matter of just throwing water at the problem. You can see here under the gauge scenario, about 21,000 square meters of recruitment success. We had a 23% increase in recruitment success under the improved scenario and actually used less water during that May to July time period. And that was accomplished by kind of starting to ramp things down a little bit earlier and following this more slowly receding hydrograph pattern. The other thing is when you throw all this water in, this is a lot of water. Daryl's kind of freaking out over here about how much water we just put down the Provo River and what he's going to do now that his reservoir's empty. So with that much more water, we did get a little more recruitment success, but only 1% difference. So again, it's not just throwing water, it's doing it in a sort of tailored way. This is kind of my last slide before I'll have Daryl talk a little bit more about operations, but when we kind of ran some of these scenarios and got some sense of how many acre-feet annually of water it was going to take to get a significant area of cottonwood recruitment, we learned it was in that 220 to 235,000 acre-foot on an annual basis. And so by running the model and getting some of these numbers, you're able to get some idea of, is this even realistic? Is this possible? Do we ever release this much water out of this reservoir? So it gives some basis for comparison. And based on water operation planning numbers, that low-end number is released from Jordanelle about 1 in 4 years, and the high end, the 235,000 acre-feet, happens about 1 in 7 years. And that matches nicely with kind of the natural recruitment frequency reported in the literature for cottonwoods. Not every year is a good year for cottonwoods on natural unrelated systems, and so it doesn't have to be, every year doesn't have to be great on a regulated system either. It's a long-lived plant. All right, well, hopefully this wrong model, I've shown that it has been somewhat useful. And Mark and Daryl can talk about this more, but it's one of its biggest values was that it provided a quantitative starting point to start coordinating with the reservoir operators. It's a lot better to come to an operator with a table of numbers that he can look at and evaluate and think about than to just say, hey, release some water for cottonwoods. You got to do it slowly. I don't know, get it up pretty high. So that it's not that useful of a tool to start with if it's just that sort of qualitative, uncertain starting point. So this model gave us some numbers to start to work from. Other point to make is not all flow ranges or recruitment services are created equal. So there's some of those particular bank areas that are a little steeper, that type of area where slowing down the ramp down rates is going to be more important, where it's worth spending that extra water, delivering that extra water down the system to allow it to be dropped down more slowly. And final point is just that we learned through doing this that increased success doesn't necessarily mean more water. All right, with that, I'll pass the mouse to Daryl.
Okay, again, I'm Daryl Devey. I'm the Bonneville Operation and Maintenance Manager for the Central Utah Water Conservancy District. Work closely with the Mitigation Commission, mostly with Mark Holden on trying to achieve these flows. One of the, sorry, I went the wrong way there. One of the first things that we do every year is we look at our snowpack. And so you can see that the graph over here shows how much water we have available on the Provo River system. This is actually this year, 2016, and you can see that we're at 88% of average, so not as good a year as we hoped for. But we have to look at the amount of water that we're going to have come into the reservoir. We have to look at, we're not the only reservoir on the system. There's 3 reservoirs above us, small ones, and there's a Deer Creek below us, which is a larger reservoir. And then the earliest priority water rights in Utah come to Utah Lake, and we also have to look at that as well. We meet together mostly in our work group to talk about where we predict the flows will be for the coming year. But the main focus of that group is not for cottonwood recruitment, it's actually for endangered species. We have a June sucker which spawns in the lower approximately 5 miles of the Provo River where it enters Utah Lake, and that really becomes our main focus, mostly when these water flows are occurring. So we really have one of these jobs that's almost impossible to perform, because we work with the commission, we work with all of our water users, we work with the other downstream users, we work with the Army Corps of Engineers who has flood control space in our reservoir, and basically tells us what time sometimes we have to release this water. And we have water users downstream who have different sources of water. In one year they may decide that they're going to use their Deer Creek water, and then the next year they use their Jordanelle water. And all of those institutional arrangements and water rights and everything have to go into the planning of this, and sometimes it makes it really difficult for someone like myself who is trying to meet all of those needs and then still trying to work with the commission to do the best thing that's right for the environment. It's been a challenge. You know, my own personal opinion is I kind of feel like we've maybe, or my own personal success feels like we've maybe only been really successful one of those years in trying to match exactly what was asked of us. The rest of the time we were trying to balance all of those water needs. And in the graph you can see some of our bigger years that we were able to provide the flows. Some of the smaller years, and especially the past 4 years, our reservoir is so low because of the drought condition that we're in that we're trying to save every bit of water that we have for our customers, and haven't really been able to provide a peak flow. But you can see that we were able to do it in 2005, 2006, 2008, 9, and 11. And, this model talks a little bit about that, and, Mark can jump in here any time and talk about this. I do know that much of this hydrograph was created because of needs for the June sucker and the pattern that the June sucker flow workgroup committee put together, and so we followed much of that down, and we were able to actually have a small recruitment window during that time. 2006, a little bit bigger water year. We had a double peak. Let me explain as well. One of the other things that we talked about is the two foreign diversions coming into the Provo River from the Duchesne Reservoir Basin and the Heber Reservoir. And one of the real challenges with those is we can't store that water. That water theoretically can be exchanged, but in some cases we have to pass that down to the other water users. And there's water right holders on the other rivers that say, hey, we want all of our water now. And when they do that, the water is just cut off. And that can be a major amount of water that's stopped without any thought of ramping that down. And as reservoir operators, we have to deal with that. 2008 was a good year. It's interesting that in 2008, we tried to provide an attraction flow for the June suckers. It really didn't help for the cottonwood, but it does show an increased flow use in about the middle of May. Yeah. 2009, again, most of this was for June sucker recruitment. The drop down was a little bit fast. There's only a limited amount of water that we can give to them, and so they're trying to scour out the river, get rid of some of the sediment, make some good spawning beds for the June suckers, and then allow a short window of larval drift, which is the peak that you can see down here, to be able to push the larva down the river to the lake. 2011 for us was a huge year, and one of the differences that you'll notice here is we started out, this graph doesn't show it, but we started out in February of releasing almost 600 cubic feet per second all the way into May and June. And that's because we looked at that snowpack amount, and we were 200% of normal, and we knew we were going to get a huge amount of water in here. And during that time period, we actually helped with some of the other tributaries who were having flooding. We took their water, put it in Jordanelle, and stored it till we couldn't store it any longer, and then thus the large peak up to nearly 2,000 CFS, and it lasted a long time. Normally our water is gone by the first part of July, but you can see that this lasted a long time. Part of that is our river basin, where we get most of the highest flows, is an area that's rock and doesn't have a lot of water seeping into the ground. And this year, there was so much snow at such a high elevation, it just kept coming and coming and coming, and so that explains that a little bit of the different years. But again, we had challenges. Sometimes we have no space to recover our water in the downstream reservoirs. We have customer demands, but our contracts tell us that when we want our water, we get our water, and so we have to be able to deliver that. Sometimes that can be detrimental, especially during the later season when you get the cottonwoods in and then they get flooded out again, and so that's been a difficult problem for us. We're able to store our water in a downstream reservoir, and in some years we have too much of that water in the downstream reservoir, so we have to get it out, and so we don't make those releases from Jordanelle on the upstream reservoir, and it makes it difficult. I've talked a little bit about our Utah Lake. Once our Utah Lake is above compromise, there's landholders that threaten lawsuits, and so we really can't bring any more Weber or Duchesne water in during those times, and that makes it difficult sometimes to be able to hit these flow projections as well. We've thought about trying to take our downstream reservoir, Deer Creek, and lowering it as far as possible. That would give us more space to be able to put these higher flows in during the springtime. But when we do that, we have sediment in the bottom of that reservoir that the stream picks up, and it carries it right out the bottom of the reservoir and down the lower section of the Provo River. There's a lot of algae and other organics in there that give us fits with our water treatment plants with taste and odor and other problems that we have. And so a real difficult time that we've had to be able to match all of the needs on the river, but we've tried, and like I mentioned, I really feel good about at least one of the years that we really got, exactly what the Mitigation Commission wanted and asked for. Mark, do you have anything else that you would like to talk about on that?
Yeah, I think Daryl's done a good job of, pointing out all of the multitude of factors that they have to consider and try to balance and work through on an annual basis. But when you're right in the middle of it, it's actually on a daily basis. Sometimes these decisions get made on how to operate and what the releases need to be. And despite all of that, and perhaps because of the longer-term involvement that our agencies, as well as many others, have had regarding the June sucker issues on the lower Provo River, we've been working on those problems, for over 20 years, and through that, we've developed some pretty good working relationships. And the reason I point this out is because you can have all the science in the world that, can provide you some guidelines for how to manage your flows to try to increase, whether it be riparian recruitment or fish habitat for spawning or whatever it is. If you don't have the operators that are able and willing to work with you, all of your effort has been for naught. And Daryl does a fantastic job of trying to balance all those needs and to try to meet the targets that we've established. And I think as we move forward in the presentation, we've got a few pictures and stuff to show you. Although the targets that we've set out haven't been met every single year and exactly, we've had substantial and successful recruitment of not only cottonwoods but willows also on the Middle Provo River. And so the project's been very successful, and it's in part due to the coordination that we have with the Central Utah Water Conservancy District and others regarding the flow management.
Yeah, I would like to have a crystal ball and be able to know exactly where everything would happen during the years. We have models that we run. We use weather service models. We have multiple tools that we use, and we feel like we're getting pretty good at it. But it's always easier to take a hydrograph after the end of the season and look back and say, I could have done this, I could have done this, I could have done this. But when the water is coming off and it's facing you daily and you have all of these other inputs, it can be a very, very hard problem to be able to solve it to everybody's needs.
All right, this is Melissa. I'll just finish up here. I want to make sure we have time for questions. We're close to the end, so hopefully you guys are still with us. As Mark said, even though some of those model runs maybe the hydrographs over the last 10 years or so haven't perfectly matched our targets, there has been a lot of natural seed-based recruitment of willows and cottonwoods on the Middle Provo River. We don't have great data to demonstrate this, but we do have some good photo point monitoring. These are kind of established GPS monumented photo points within the restored areas where repeat photos have been taken. So they give you some idea. They weren't specifically established for cottonwood photo taking, but they give you some idea of some of the areas where we've seen success and give us some insights. So I'll just go through a few series of photo matches in these next slides. On this slide, the pink dots, I just have our kind of one of our model outputs for reference, but it doesn't match any specific hydrograph. So these pink dots are the photo point locations, and this photo point is kind of in a low point in the restored floodplain. I think it's in an area that was originally an old ditch, so kind of a low spot with some potentially other water sources besides the river itself. So this is in 2001, immediately after restoration construction. And you can see within a year, a lot of grasses and so forth are kind of establishing along that wet area. By 2005, we're starting to see some woody vegetation, at least some willows in that area. 2010, things are growing up. You can kind of see how the water is disappearing as well as the vegetation encroaches into this low spot. The rocks, the cobble rocks are disappearing. And this is the same spot in 2015, and all you can see is a bunch of leaves. So a very successful location. And again, success in this area might not have been predicted in our model, but it could be a function of that good contact with groundwater that's not directly related to river overtopping its banks. This is another sequence down in a different area of the river. This photo point is on this southern bank, and the photos are taken looking across towards the north, looking at this point bar and the mouth of this side channel in this next sequence. So this is that area during construction, and this is kind of the area I want you to focus on in the next sequence of pictures. Within a year, again, just some kind of herbaceous plants that you can tell are coming in. By 2005, you can see some of the shrubs coming in, the willows. And we had good water years in 2003 and 2004, quite a bit of flooding that really set up some good seedling recruitment early on in the project. 2010, it's really filled in, and that vegetation persists through to today. One other thing I noticed when I was looking at these earlier today, you can also kind of see that these mature cottonwoods, which were old when the project started, are looking a little less healthy over the last few years. So it's good that we've gotten some new recruitment to help get some taller trees growing up in the project area as those mature ones start to die out. Last sequence here that I'll share within the modeled area, this photo point's down here, kind of taken looking up this side channel. And you can see a lot of green in this model output. So this is maybe a hot area for potentially getting good cottonwood recruitment. This is during construction, at the end of construction, vegetation starting to come in a year later. In this area, the pink circle, again, it's a little out of focus, but we've got some pretty good willows coming in on the banks of that lower side channel. Lots of good vegetation in 2005. And then, whoa, 2007, a lot of water everywhere. What's going on? Well, the beaver have been in the area, so they definitely have had an effect on some of that vegetation that came in. And that in present day, kind of in a pond, so some of these areas that had recruited up probably got flooded out. John shared another sequence of slides where you could see the influence of beaver, so that's sort of another factor to consider that definitely wasn't part of our model. This is another part of the river, not our modeled study reach. This is the old river channel that got filled in as part of the restoration project. You can see the seedlings established here, starting to grow up. And then the beaver came and chomped on everything. But the project area was able to recover. So beaver are definitely a factor. They can be a plus or a minus depending on your perspective. This last photo matching sequence is from some other geomorphic monitoring work that's been done more recently. And this is a site on the, about 6 miles downstream from the reach that we modeled, where you can see a sequence of the initial River right after construction, 2006, you can see these large gravel and sandbars that kind of got thrown up in that high flow season that year. And something that's happening on this lower part of the river, which is below that never channelized reach that Mark pointed out earlier, that provides a sediment supply for bar formation to create that sort of step one in our recruitment requirements to have that bare, moist surface with bare sediment. And you can see that between 2006 and 2008, you don't really see those bare gravel bars anymore because woody vegetation is established down there. So again, a reminder that beaver can interfere with your good plans. Even if Daryl does his magic and hits that target right on in a given water year, the beaver might come flood everything out with where they decide to build their dam. Oh, so I'll leave you guys to ponder whether beavers are superheroes or menaces. Probably won't figure out the answer to that in this webinar. Finishing up with just a few lessons learned and challenges. Obviously, a lot of difficulties associated with actually matching those flow recommendations given all the factors that go into deciding actual reservoir release patterns. Lack of sediment, we touched on that a little bit where I pointed out that that section of river downstream from the never channelized reach has a good sediment supply where there's kind of material with which to create these bare sediment surfaces where seedlings can germinate. On the upper section of the Middle Provo, below Jordanelle Dam, which blocks all the sediment, that could be a limiting factor, again, in sort of being able to meet this requirement number one of that bare surface with fresh sediment at the time of seed dispersal. A couple thoughts in terms of applicability to other river systems. This sort of approach is certainly relevant to any system with some springtime flow release operational flexibility. If you're operating a reservoir and are not, you know, even more restricted than what Daryl is in the way you can release your water, there might be some flexibility to start thinking about cottonwood recruitment in the way you release your spring runoff patterns. This type of model can also be a tool for restoration project planning. Maybe your channel is fairly incised or diked off and you don't have the money or interest or space to kind of do a full-blown floodplain reconstruction like the Middle Provo River, but maybe you could do some bank work in a particular area or take down the levee and lay it back in one small spot. You can kind of think through this type of model to help you design those surfaces to match typical flow release patterns. Figure out where the steep parts and flatter parts need to be to work well with your release patterns. One other thing I wanted to point out is that it's not necessary, it's helpful, but we did that kind of fancier two-dimensional river 2D modeling approach with the groundwater component. There are simpler, cheaper ways to potentially come up with a model for your system. Also want to point out, John asked me earlier, he's like, so what would it take to do this again? I'm like, well, I'm pretty sure you wouldn't do so much total station surveying and 3D stereoscopic orthophoto interpretation when you could just have LiDAR flown, something like that. So there's some newer ways to more efficiently get good topographic information. And again, these simpler modeling approaches could be something where you use a HEC-RAS model. I'm assuming there's probably some folks on the webinar that are familiar with those models. One-dimensional hydraulics model. This top graphic shows you kind of that kind of output, a sequence of cross-sections that allow you to look at stage-discharge relationships. WinXS Pro is a real simple, free online software package. This is its output. So if you all you know about your topography is one good cross-section that's maybe representative of a reach, you can run that model and come up with some idea of what flows inundate what surfaces and how slowly you need to drop those flows to not exceed those recession rate guidelines that we developed. Yeah, basically any technique that allows you to be able to look at depth and discharge relationships will allow you to kind of evaluate flow required to initially inundate and wet a particular recruitment surface, and then figure out what an appropriate ramp down rate would be for that surface. And we're not quite on 3:30, but we're not too far behind. So I think, Mary, if you want to let folks know how we can work through questions.
Thanks so much for all that great information. So if the audience has questions, hopefully you do, you can ask questions by typing them into that chat box and sending them to the host, and then I'll read them to the panelists and they can respond. Also, you can ask questions or provide comments via phone, and to do that, just press *6 on your phone to unmute yourself, and then you can, when you're done asking the question, you can remute yourself by pressing that *6 again. So I don't have any, there was no questions asked. We'll give people a little bit to formulate questions by typing them in. But if anybody has a question that they'd like to ask via phone, please feel free to unmute yourself by pressing *6.
Well, since there aren't any questions, this is Darren Olsen. There was one aspect, one objective that I kind of think would be important for people to hear about, and that is that the Provo River, Middle Provo River restoration project, took several years to complete in phases, and one of the objectives was to use the information on the earlier reaches that were constructed to help with the design of the other reaches that were still to be constructed. And I think what Melissa hit on towards the end, that it provided some help in designing the channel and floodplain for the recruitment of cottonwoods, and I think that's an important aspect. We also were looking at other aspects, including in-stream flows for fish habitat.
Great, thanks.
Yeah, Darren, this is Mark. That's a good point. This was the second full year of construction. And so we didn't have a whole lot of study sites available to conduct this in. We selected this site, but then we did apply the results, the outputs. One of the things that we tried to do then in subsequent design and construction of different reaches was to slope a lot of those banks a little bit more gently. The idea behind that then was based on the recession rates. We could see that dropping the flows more quickly had a greater impact where you had your steep banks than if you had a more gradual bank. And so that did influence the design and then the construction work that we conducted on other reaches downstream.
Question we have so far in the queue. If anybody has a question by phone, please butt in. You're welcome just to butt in any time. But someone's asking about the presentation materials, and we are recording this webinar, and we'll send the link to that recording to everybody who came to the webinar today, and we'll have that, and then also access to the slides and PDFs.
Good afternoon. This is Stuart Rood. Can you hear me?
Yes, Stuart.
First of all, my sincere compliments to the group. This is a really exciting case study. I might note that I'd been to the Provo 25 years ago with Chad Gorley, who was involved early on, so it's really exciting to be brought up to date on how things are going. As the seminar went along, I've got pages of comments and notes, and it's really exciting for me. We've been involved in fairly somewhat similar systems across the western region, and what you have is a number of insights that I think are really instructive. None of us has a crystal ball, and it is indeed easy to look back at hydrographs at the end of the year, but it's been quite interesting to follow the success that you made. And I might comment that we think of the natural flow regime as being the template, but while the natural flow regime is sufficient, it's not optimal. And I'd argue that the same applies for any managed regime. So we'll never be perfect, but it looks like you've done a real good job of sculpting a landscape that's available that restores access to the riparian zone, and balancing the challenges relative to not only floods, but perceptions of flood risks, dealing with aspects such as fish that sometimes are on your side and sometimes working against. I wasn't surprised that willows are bouncing back better at the onset, and that's very encouraging. And so I look forward to following this more, and I will send some comments along by email to the group. Again, congratulations and sincere thanks for bringing us up to date on this.
Thanks for your comments.
We got a couple thank yous from the audience in terms of comments, but no questions. Anybody else on the phone would like to chime in?
This is Mark again. I'd just like to give a shout out, and Stuart mentioned Chad Gorley. Chad worked for the Mitigation Commission for several years, and I kind of hired him away from the Nature Conservancy to come back and head up the Provo River Restoration Project, and he's really the one that helped get this going with some credibility and some science, and pulled together a great team of experts to help influence that design. And he also convinced us then to hire another young fellow that he had met by the name of Tyler Allred. And we hired Tyler, and he worked for us for several years as well. Each has since left our agency and are on their own doing private consulting work, but they were both just a tremendous asset to us as we did this Middle Provo River restoration work, and they deserve a lot of credit for how successful the project has been. You know, could it have been done, you know, differently a little bit or improved in some way? Sure. We've learned that, particularly, and as Darren pointed out, we've applied information that we learn from one reach to the next reach. And so it took about 8 years of 6 months or more annual construction to complete the restoration work. We installed and paid for about $500,000 rooted plants to be planted of various types. And as you can expect, that's really just a drop in the bucket to compare with what, if you get the surfaces aligned properly and you get the flow rates delivered properly, the natural recruitment far exceeds anything that we did through our revegetation efforts. And we recognize that from the beginning, and that's why we set out to try to, you know, develop this model as a guide to us to help design and then manage the project for years to come.
Great, thanks. Well, we have no questions in the chat. Maybe I'll call out one more time to the audience for any phone questions.
I guess without any questions, this is Darren Olsen from BioWest one more time. One other, you know, aspect that was already talked about, but I think needs to be reiterated, because I haven't seen this as well done on any other systems, and that is being able to work with the Central Utah Water Conservancy District, and for them to do everything in their power to deliver flows that are being requested. And Daryl has done an amazing job of balancing all those items that that would make anybody else go crazy to do that, and at the same time delivering flows in the lower Provo River for June sucker recruitment has been quite amazing, and we kind of learned in the mid-90s how to work, you know, to get specific flows, and we were doing these sediment transport measurements also, and inevitably it was over Memorial Day weekend that, you know, our peaks would come and people would have to work overtime and whatnot, and they were willing to do that throughout, and so that's been an amazing relationship.
Great, thanks. Well, maybe we should get anything else from the panelists. Would you have any closing thoughts that you'd like to share with the audience before we wrap things up?
No, I think we're good here.
All right. So, yeah, no, it doesn't appear that we have any more questions, so we might as well close things up. Just like to remind everybody that we will follow up with you with the link to the recording as well as a PDF of the slides. And I just want to thank you all for attending. I'd like to thank all the panelists, John, Mark, Melissa, Daryl, and Darren. Thanks for taking the time to be with us today. And again, thanks to the audience, and I'd just like to say goodbye and enjoy your day, and hopefully we'll see you on future Southern Rockies LCC webinars. Goodbye.
Thank you for having us.
You bet.